important. And that's certainly what's going on, again, in labs here at Berkeley and all over the country. There's these techniques of gluing in pieces of DNA. They're not completely novel, but in the way of standardizing the way that the pieces can be glued together, and in the way of simplifying it, it becomes the rate of innovation, I guess, becomes greater, and so more useful stuff like biofuels and like bacteria that can target cancer cells and inject lethal proteins into them, like Dr. Anderson's lab has demonstrated, and other things, and bacteria that can see light and can make an effective film, or bacteria that can metabolize toxins from the soil or from water pollution. All those are pretty useful things that basically have come from gluing together either an enzyme with another enzyme, or a metabolic pathway with another metabolic pathway, and so on. So yeah, to sum up, we've got standardization and simplification of the processes of genetic engineering and the application of those processes. And I guess that's synthetic biology, as best I understand it. Although there's a really good professor upstairs that could probably give you a better answer than what you just got.
I don't know, it's pretty fantastic.
All right, cool.
No, it's fine. I don't think we should take too much of this time.
Okay. I'm really a productive and efficient worker, and so yeah, taking 5 minutes of my time really hurts this lab a lot.
It hurts humanity a lot.
Thank you. That's right.
Okay, so I'm going to try out a question. If you need to ask me questions about the question.
Okay, sure.
But these are coming from Paul, my boss. So
Okay.
the question is, very simply, so like, what is flourishing?
Flourishing.
What is it? What like?
What parts of synthetic biology are currently flourishing?
No, how would you describe? How would you describe the act that synthetic biology is trying to make life better, help people?
Oh, so how would I evaluate synthetic biology's progress towards that goal?
Or how would you define like having a
Oh,
good life?
so what would success in synthetic, if synthetic biology was successful in its goals, what would that look like? Is that?
Oh, yeah, I like that question.
In what way could we expect life on Earth to flourish as a result of synthetic biology? Is that closer?
That's closer.
Okay, so what could you expect from synthetic biology? You could expect certainly biofuels, right? That's the big head honcho of goals for synthetic biology right now, is the notion that you could get a vat of either algae or bacteria that could take either corn, not just the kernels of corn, but the husks of corn and switchgrass and lawn clippings and raw sewage or whatever nutrient source that could be foisted onto a bacterium, and have that bacterium take it and turn it into stuff that you could put into your gas tank, right? And that would be extremely useful. Synthetic biology coupled with engineering hopes to scale that down in the same way that the personal computer was scaled down, and you could basically take your compost pile that you have in your backyard and your garden and instead turn it into a synthetic biofuels vat that you could, every time you mowed your lawn, you could, throw your lawn clippings into a big vat, and I guess this would be in the distant future, but at the bottom of the vat there would be a spigot that you could put into the gas tank of your car. So that would be pretty cool. Certainly medicine would be a useful, is the other thing that certainly biology spends a lot of time on and gets a lot of funding for, and has high hopes for. And so yeah, bacteria that can or other cells that can target, specifically target a cancer cell, right? And have that cell that targets the cancer cell, administer a lethal, a touch of death to that cancer cell. That would be pretty cool, right? Also, again, having bacteria that can clean up a toxic waste dump by having a bacteria that can metabolize a toxin like PCBs or diphenyl. Yeah, I don't really know all the toxins, but there's a lot of toxins out there, and if the toxins are made out of organic molecules, then you can find an enzyme in a bacterium or somewhere else that can destroy that organic molecule and render it less toxic.
So another question I had is, synthetic biology is about creating or designing novel life, novel organisms.
Yeah, I guess there's been talk about, when you say novel life, yeah, I guess there's been talk. I guess Craig Venter has said, oh, we're going to create out of scratch a completely new genome for a completely new bacteria, and that's a possibility. I wouldn't say that's the closest goal, but that is a sort of a, can we actually do this kind of goal? Yes.
What do you think the limits of designing an organism would be?
So the limits of designing an organism, that's a big question. Yeah, so well, I mean, the limits are basically, there's, if you want to send yourself far into the future, the limits get, naturally, as you would expect, less and less. Dr. Anderson has worked on, I mean, most of the time when you work with DNA, you're making manipulations to a protein. And proteins are made out of 20 different amino acids, make all the proteins in your skin, your hair, your eyes, and so on. But if you engineer a bacterium, as Dr. Anderson has managed to do, you can get them to make a different amino acid, and so all the proteins that would be made from that amino acid would be different from any other protein that's existed before. So that opens a tremendous amount of possibility in terms of what kinds of things could be made, what kind of enzymes, what kind of chemical reactions you could get a living thing to do, what kinds of physical properties a protein would have, and whether it would be a useful material, such as like spider silk. You could make an improvement on spider silk and have that be an actual thing that you could build out of, or get a bacterium or other creature to make, and then use it in your everyday, I don't know, clothing or ropes or bridge cables or whatever you want to make out of it. So there's a lot of different things